Okay, so this is supposed to be full screen. Okay, so in here, I'm going to talk just a little bit about, and have you guys participate too, about some things we can do based on what research tells us about how people learn, how we can perhaps design our courses to encourage more long-term knowledge retention. And we're going to focus on just a few specific techniques. There's many, many things you can do to increase student learning, but we're going to focus on just 4 things here: the use of retrieval practice, space practice, interleaved practice, and metacognitive reflection, because these have been found to be important in many, many studies over quite a few years now. And let's just talk a little bit about each of them. The retrieval practice has been known for a long time, and it was first called the testing effect, which the term was derived or devised in 1909. So it's something we've known about quite a bit. And what the testing effect suggests is that the more you're tested on something, the more you remember it. And in some ways, that gave retrieval practice a bad name because people associate it with just lots of tests. But retrieval practice is more than just being tested on things, that there's lots of things you can do. And we'll talk about a few things now. What happens, though, is the way students tend to study and the way we often encourage students to study is not by retrieving information, but by repeatedly trying to store it. And by rereading things over and over again, by memorizing the things that they've read in some sense. And after rereading something one time, there's generally no significant improvement in how much people learn by looking at a document multiple times. And that's been shown in quite a few studies. What seems to be most effective is practice retrieving it. If we want to be better at being able to recall information, we tend to get better at it simply by practicing recalling information, building those pathways to make it easier, those connections that make it easier to recall things in the future. So to become better at remembering things, we need to practice remembering things and retrieving information. And here I have I put in a Jamboard, and I'll share the link with that with everybody. And I thought maybe we could just talk about some things we might do in our classes to help students, or that we could build into our classes in which students might do some sort of retrieval, some practice at retrieving information. And the easiest way to do that is with a sticky note tool, where you just click on this little thing at the side and you just type something. You can change the color, you can move it around, you can rotate it, but just put up, it's all anonymous. So think about some things you can do. Repeated low stakes quizzing is one of the things that people do a lot. Spiraling curriculum. What is that? I've heard the name, but I'm trying to retrieve it and failing.
It's where students learn, several different concepts, but, so you learn the 6 different concepts and you learn each of them at level 1, and then you go back and learn each of them at level 2, then you go back and you learn each of them at level 3.
Okay.
So you're constantly repeating.
Okay. I was kind of thinking that, and they redesigned the math teaching system a couple of decades ago in New York State to try to do that with math A, B, and I forgot the terms.
It was just math actually. A and B, and then they went to the upper level math.
And then, yeah, but at least they did have that same sort of practice. And you're right. Yeah, I forgot that specific term. That also involves something we'll talk about in a minute, which is also interleaved practice and also some space practice, which are also important. So a spiraling curriculum can do that because in order to get to the next level, they had to retrieve and practice what they had done earlier. Any other things? Repeating, and you'll have access to this later, so you can always come back and share more things later. repeating concepts, but making connections with other concepts is also really helpful. The more connections students form, the easier it is for them to remember the concepts, because we don't remember things that well in isolations. We start off trying to remember things in isolation, but the more we can connect new concepts to other things we've learned and apply them in new contexts, the more deeply we'll remember them. Making connections to real life concepts is good, because that involves, it's building connections as well as trying to think about applications, looking, not just focusing on the theory, but also including applications like how this connects, which involves what we call transfer, taking concepts and applying them in new connections. Okay, and that'll still be there, and you can keep adding to it. But let's move on to some things I put together, and low stakes or no stakes practice tests. Mastery quizzing is one way. That some other simple tasks or simple techniques that people have used is, if you're meeting synchronously, just have students at the beginning of the next class summarize what you had talked about last time. It's a really simple retrieval exercise, but it can also help activate prior knowledge. It can get people primed to think about the topics so that they're ready to start making connections to what you're doing now. And you could, common techniques to have people talk to each other about what they did, what you had done, and then you could even then try to have them predict what's going to come up next if you haven't already explicitly told them that. An activity that many people have used, I haven't tried this yet, but it's called a brain dump. It goes by other names too, but have students just pause periodically in class and have students write down everything they remember about a topic. Or you could have them do it at the beginning after they did some sort of reading assignment or watched a video, or after you go through an example in class. After they've had some learning activity, just have students jot down things that they remember from it, and then work with someone else so that they can share their reflections and combine these, and then ask students to report on it. You know, it could be a simple, again, think, pair, share activity. You can always use things like clickers or polling software, where you can have students, where you can quiz students on things they've read, or you can try to make connections too. You could try to get them to apply things they've just learned in new contexts, which will also force them to develop, again, to retrieve some of those concepts and apply them. Kahoot is a fun thing many people use to do this periodically in a class. And you could also have students create questions where they quiz each other. Another technique that some people have used very successfully is using reflective blogs or journals where students reflect on what they've learned, which means that to reflect on it, they have to think back on what they've learned. And another concept that works pretty well is just something as simple as an exit ticket, also known as a 1-minute quiz or a muddiest point thing, where the old standard way of doing this was have students just jot down on a piece of paper on an index card something that the primary thing here is to think back on what they've learned that day and to write down perhaps what they've learned, but perhaps more significantly, what they don't quite understand, and share it back with the instructor. That would be the muddiest point aspect of that. And there is at least some studies that have found that just doing this for literally about a minute at the very end of class has led to significant improvements in student learning. Because I know in particular, there was one economic study that was done where an instructor taught 2 classes the same way, the same activities, one of which he used the 1-minute quiz at the end of each section, and the other he didn't. And he ended up with learning gains of about 7 or 8% from the pre-test to post-test on a standardized instrument when students were exposed to that simple reflection activity of just reflecting back on what they did that day in class. So other studies have found smaller or insignificant effects, but it is a form of reflection, which can be useful, but it does force them to think back and reinforce some of the concepts they've used. You can also encourage students to do this. And when we had last year our reading group for the 2019-2020, focus on teaching students how to learn. And Sandra McGuire came, and one of the things she talked about was some ways we could encourage students to do this. And students could work with flashcard apps, with random shuffling of concepts if they need to recall things. But perhaps a more useful way of doing it is having students explain things to each other. She told a story of how one of her students didn't have someone she could talk to because of where she was living or whatever. And so instead, she tried to explain everything she learned that day in class to her goldfish. And the act of putting things together and trying to explain it to other people or to your pet, or one of my colleagues, Liz Dunn, often mentions that she'll tell students to try to explain things so that their mothers would understand it, or some relative who has never studied economics might understand the concept. And the act of explaining it forces you to pull things together and make sense of it in ways that you might not if you just work through it and then you drop it at the end of the class day. You could have, or students could quiz each other or practice with each other and try to explain things to each other. There's also things that students can do on their own. There's lots of online quizzing tools in many disciplines, review sites, some of which are on the open web. There's Quizlets, and there's lots of similar types of practice that publisher content provides that you can always put into your classes just to give students more practice. When doing retrieval practice, it's important that students do get some feedback. Just asking them to retrieve information without providing a mechanism for feedback is generally not as helpful, because if they're trying to recall things and they're getting something wrong, that can reinforce concepts that are not very helpful, that can be detrimental to building a strong foundation in the discipline. So that's where clicker use, for example, or polling devices can be really useful. You can give students problems, you can get the answers, and you can see how they're doing on them immediately, which allows you to go back and say, well, you could ask students to explain their arguments, and then you could help lead them to a better understanding or help clarify any misunderstandings or misperceptions. So whatever techniques you do with retrieval practice, it's important that students get feedback so that they're not reinforcing inaccurate or incorrect understanding of whatever it is you're trying to have them learn. One interesting result is that retrieval practice builds automaticity. It gives students a strong foundation where more concepts become automatically available, where they can quickly retrieve concepts and blocks of concepts more easily, which gives them a stronger foundation to build new things on. But the more practice students have in just retrieving concepts, the easier it is for them to engage in applications, to take those concepts and apply them in new frameworks. So the better they are at recalling information and the stronger the networks they develop, the easier it is for them to see how things connect otherwise. Up to a point. We don't want to get to the point of rote learning where students memorize things, but too much retrieval practice or too much use of this can lead to a decline in creativity. And there's some research there. So you don't want to carry it too far, but retrieval practice is useful in building recall, but you also want students to be able to engage in transfer. So the more you can have them take the concepts they've learned and apply them in new environments, probably the better in terms of developing more ability to use the concepts that they've learned in new contexts. The next thing, the space practice, is, I think most of you have seen this before. I know some of you have done some work with this before. And space practice basically is just spreading out the time you spend studying. And there was this classic study that was done back in 1979, and similar results have been found in dozens of other studies, where when you space out studying, students don't do quite as well. This was an experiment where classes were scheduled on a topic. There were a total of 6 class sessions. In one case, the classes were scheduled back to back, one day at a time. In the next, they were scheduled every other day. And in the next case, they were studied a month apart. And what happened is students were asked to were tested on what they had learned in the earlier classes after the second session, the third session, the fourth, the fifth, and the sixth, and then they were all measured a month later. And what happened is that the students, that top bar, the one right here at the very top, were the students who did really well. The students did really well when they had back-to-back classes. So if you're teaching a 3-week class, students will come in remembering an awful lot the next day and the following day. They'll remember things that they've learned recently. When the classes had a day in between them, students didn't do quite as well. You know, they were over 80% when they were one day later, but when they had a day in between, they were only somewhere around, it looks like a 54% or so. But you notice they do start to converge a little bit as the number of days continued. The students who had classes that were a month apart did really poorly in remembering what they had last seen a month earlier. But when they were all tested a month later, the students who had a month in between or 30 days in between their classes ended up having by far the highest score. So they ended up doing better than those students who had learned things more quickly. And, you know, basically the point here is that a lot of research has shown that when you space study sessions, if you try remembering things you studied recently, you don't remember them as long. That what the research suggests in general is that, oops, I thought I had another slide in there. In general, you remember things the best if you go back and you try to retrieve them when you're on the verge of forgetting them. So retrieving from earlier in the course is a much more effective way of building long-term memory than if you repeatedly engage in retrieval practice in a very short period of time, which we know is kind of the opposite of how students tend to study. Particularly students who have high stakes exams tend to do a lot of cramming, and they'll remember things really well for an hour or a few hours or maybe even a day, but they tend to recall very little of it later. And so if we can encourage students by our class design to space their study, which some of the concepts that were up on that Jamboard were consistent with, then they're going to remember a lot more. So what we can do then is, well, let's go back to that Jamboard for a moment. And if we go to the second screen, there's a page for space practice. What are some things we can do to encourage students to space their study practice, their study sessions? We all tend to procrastinate, that we all tend to, many of us at least, most of us tend to wait until the last minute to do many things, because when faced with a choice between something fun and studying or something similar, many people would choose to do something that provides immediate gratification now, and study doesn't always do that for all of our students. How can we build in space practice into our classes? Staggered deadlines can work. Instead of just having, 2 or 3 or 4 exams in your class, give students lots of smaller, and that's consistent with the low stakes exams, right? Having students can get around this by having weekly or biweekly study groups, which also forms a commitment device, that if they agree to meet with their peers at a certain time, that puts peer pressure on them to actually do that. It's always easier to skip studying if your friends are coming to your door saying, hey, let's go out now. But if you have friends saying, well, you agreed you were going to study with us every week at this time, that can be really helpful. Including questions from previous units on current tests is a really good way of doing that. If students know that they're going to be tested not just on what they learned this week, but by what they learned a month ago or 2 months ago, that's going to encourage them perhaps to space their practice, or at the very least, they'll learn to do that when they know that those things are going to come back. So that can help too. Okay. Giving some quick feedback so they can spend time reflecting before the next assignment can help. Designing projects that use multiple concepts that involve past concepts from earlier in the course. So if your classes build on things learned earlier, it's perhaps easier to do that. Or design your class like that spiraling technique is one way of having people go back to those concepts after they've been away from them for a while to deepen and extend the length of time we remember things. So having projects that use multiple concepts, particularly some from earlier in the course, is a good way of doing it. Okay, those are all good techniques. And I think that's pretty much what I have. Having questions from an earlier part, connections to earlier material. Another thing that people use, which was implicit in there, is you could have progressively cumulative exams. Instead of having 2 or 3 exams, you could even have weekly exams that will build on everything you've done up to that point, where there's, more of the material could be on the most recent concepts, but have some questions that go back and build on earlier things. I actually ended up doing that last semester in my large class that was taught synchronously. I had weekly quizzes, but a portion of each quiz involved a random selection of concepts from earlier parts of the course. Another thing you can do is, if you have a structure where some portion of your grade is based on perhaps a mastery learning component, you could allow students to go back and do better on any of those earlier quizzes at any point in the class, because students don't like to leave points on the table. If they find that there's some concept, if they didn't do so well on an earlier quiz, if you let them go back and redo it, and the grade book will automatically update if they do better, that provides students with an incentive to go back and retry some of the concepts they didn't master, because it gives them a great improvement, as long as they're not going to be harmed by it. If you only keep the highest grade in your grade book, and it doesn't have to be a large share of it, that would be a good way of doing it. Now, another concept which is often related to space practice is interleaved practice. Block practice is when students learn a new concept, they practice it, and then move on to another discrete concept. And this is a way most textbooks are structured, and many of our courses have been structured. And this is perhaps in some ways the hardest type of thing to move away from. And that's, again, where that sort of spiral curriculum approach could be really helpful, where you keep coming back to the same topics, but at higher and higher levels. Because most textbooks, though, focus, let's say a math textbook, you learn a certain type of equation and how to solve it, and then you move on to a different type of equation and how to solve it, or a different type of problem. Most physics textbooks and chemistry books are built in this way. And so our courses are often associated with texts that do not do well. Interleaved practice is the opposite of this, where you have concepts that are mixed together, where you're not tested on just one concept, you're tested on a mix of concepts, or the applications you have to do involve a mix of these. So there's a mix of topics or skills that you're being assessed on and where you're practicing. And this is one that's often kind of hard to do. When one of the authors of Make It Stick was here, he noted that actually he was attending one of our reading group meetings, and he noticed that one of the authors of Make It Stick, one of his co-authors on Make It Stick, was in an adult hockey league, and the person coaching it would have them work first on one skill, and then just when he felt they were getting good at it, he suddenly moved to another skill, and then he moved to another skill without ever letting them get focus on the one skill. And as he was complaining to his spouse about that, he realized what he was complaining about was that the coach was actually using interleaved practice, which his research had shown to be really effective in learning. So with interleaved practice, you switch from one thing to another, or you have to determine which skill is most effective. And actually, most sports trainings have realized this for quite a long time. You'll have students do some if you're coaching a youth sport, for example, you'll have students work on perhaps let's say soccer, you might have them work on dribbling or on passing, but then fairly quickly you move to new skills where they have to combine them and switch from one to another and choose which one to use at a given time. And that's more complicated, but that interleave practice leads to more skill development and more long-term development of skills. This is a classic study where students watch 4 videos on computing the volume of 4 three-dimensional objects, spheres and cylinders and prisms and pyramids, I think they were. And basically, in one case, they watched the 4 videos and then they were tested on them one at a time. So they watched a video, they took a test, and they were tested on their ability to apply the concept. Then they watched the next video and they were tested on it. That was the block practice case. And when they were doing the practice performance on it, the people who watched the video and then answered, I think it was 10 questions on it, did very well. They averaged about a 90% correct in applying the concept. But when they had interleave practice, they watched exactly the same videos, but then they were given the same questions, but in random order. So students would not just take one formula and plug numbers into it. They had to recall which formula to use, which formula applied, remember all 4 of them at once, and then answer it correctly. They did a lot less well. But when they were tested a week later, the people who had the block practice, this was multiple choice, I believe, the block practice essentially had forgotten everything. But the people who had the interleave practice ended up doing substantially better. And they also, another experiment, there have been many, many of these. There was an experiment where people were learning how to throw a ball into a basket. And in one case, they had 3 different distances where they had to throw it in, and they practiced from one distance, then the other, and then the other, and they did pretty well. But then in the other case, they kept moving the player around, and they had them from different points try to throw it in, and their accuracy was much lower. But then when they tested them in terms of their ability after some time to throw it in from a random location, the people who had practiced the interleave practice by varying the conditions and forcing a little bit more processing perhaps of how hard to throw the ball ended up doing much better than the students who had the block practice, where they were just practicing from specific fixed locations multiple times. So interleave practice, mixing problems up and having a group of problems, can also be fairly helpful. And again, some of the concepts we've already seen, I think, would fit there, but there's the next slide there. What are some ways in which you might, or which you have, or you might, or you know of people who tried to generate interleave practice? Again, it's often hard to do if we're following a textbook order of things, perhaps, because textbooks are generally devised in a very linear, structured way, where you learn one concept, you move on to a new one, and you often leave the old one behind, in many textbooks at least. Any thoughts on how to build interleave practice in? Well, let me ask it another way. Would most of the things you've posted for space practice also apply for interleave practice? By having questions drawn from earlier parts of the class or using a type of spiral curriculum, would that basically also be providing interleave practice?
Yes, I was trying to think of new things and I wasn't being successful.
And that was my issue too. I put together some notes on this, and I grouped these two together often because pretty much anything you do to space a practice will generally also automatically provide interleave practice. I suppose one thing is if you're giving a test using if you're giving a test using real life experience, more complex problems would automatically build interleave practice, where you're not just plugging numbers into a formula, you're trying to determine what model somehow is most appropriate. So higher level problems, more challenging problems, kind of also forces interleaved practice. But anything where you're going back and you have to think not just of what numbers to plug into what situation, but where you have to think about moving higher in Bloom's taxonomy will automatically give you more interleaved practice because you're pulling more concepts together. Capstone courses and internships can do the same thing. I think, who is the author of it? I'm trying to think of the author. It might be Paul Hanstatt. Has a book called Creating Wicked Students, where he suggests that, one of the things we should focus on, particularly in some of our upper level classes, are not just treating students to solve problems that we can easily categorize, but give them some real world problems that make it where they have to bring together a lot of different concepts that they've learned earlier, because they're going to learn them much more deeply when they're forced to apply them in specific, complex, and messy problems that don't have that sort of well-defined solution that often shows up when you're engaged in block practice. Right? In block practice. Okay, well, moving back. So most things, again, that work for space practice will also do this. Don't just use block practice and assessment. Don't just test students on one specific skill, although you might want to use a mix of that. If they're learning something brand new, some block practice may be helpful, but then once they've got the basic concept down, apply it in some type of interleaved practice. So if students have learned 4 or 5 different ways of solving different types of problems, you might have them do some initial block practice on each of those, but then mix it up, give them some type of an assessment or some type of practice where they have to switch back and forth among all those, perhaps. You can also encourage students to mix up their own study practices. And some of the authors of Make It Stick and other people who've done this have encouraged students to use flashcards, and there are flashcard decks where you just sort the flashcards. If there's different concepts you want to be able to remember, or different formulas or something similar, or different types of problems, just randomly sort them so they're coming at you in different order. And that can be helpful, and just to review it. Don't just study things in a predictable way, mix up your studying. And yeah, flashcard apps. In general, encouraging students to switch from one topic to another. If they're reviewing, they don't have to do things in the order in which they're reviewed in the book. In my large intro class, I let students redo many of the quizzes multiple times, but they're narrow, but they are, to a large extent, many of the quizzes are mastery quizzes on specific concepts. I tell them in reviewing for their exams and to pull things together, that they may want to just go back and randomly choose which concepts to work through. So work on one type of problem for a while and then jump to a different type of problem. That's automatic. It's not quite interleaved, but at least it's giving them a little bit of interleaving to that. But when I have assessments, let's say weekly assessments, they will involve some space practice and some interleaved practice, because I'll have random drawings of questions from earlier in the course and in a variety of applications. And those are much more challenging than the mastery learning quizzes on more specific concepts. Now, the last concept I wanted to talk about was reflection. In general, the basic principle, and this shows up in a lot of activities for us and our students, is we become better at activities when we reflect on our experiences and learn from them. And this is something that we don't always encourage our students to do. And here we can just know, I just put a few things up. One thing you could do is have students, again, I mentioned this before, but having them reflect on their learning and what's worked for them and what didn't work, or have them journal, and record how they've learned this new discipline or their learning experience. Another simple thing you can do is, after you have significant assignments or exams, you can use an exam or assignment wrappers, where you ask students to reflect on the process they used in completing the activity. If they wrote a paper, you could have them reflect on how they research the paper. You could have them reflect on how they organize the study and how they engage in writing. With an exam, you can have them reflect on how they prepared for the exam and how they did, and ask them to reflect on what they might do differently next time. And a common practice with this is if you do have 3 or 4 exams, you might, after the first exam, give them this exam wrapper, collect those, and then send them back to them a couple of weeks before your next exam, reminding students of things that they thought would be helpful, to remind them that maybe they could, improve things if they paid attention to their own words in the past. You could also periodically in class talk about how students are, or have students talk about what's working for them. That could either be done in a synchronous class discussion, or could be done in a discussion form, no matter what your modality is, and just have students share their experiences on what's working for them, what they're struggling with, and have them share with each other ways in which they found to be helpful. You could even give them some readings. One of the things I've done is I've had a low stakes discussion forum in a couple of my classes where I'll have students read something about retrieval practice or space practice, or the importance of sleep, or similar things, or something about growth mindset or other activities, and then have them discuss that in a discussion forum. But letting students share their learning journey with each other and reflect is another way of having them reflect on their own experiences and learning from each other, where, if students tell other students that they found they did a lot better when they stopped cramming and they started spreading out their study practices, that's much more effective than reading an article on that or having an instructor tell them that. And students have generally reacted really positively to that. One thing I wanted to note, though, and this is a challenge with all of these things, is that when you use these activities in your class, they're often somewhat new to many of our students, particularly our freshmen, because in general, they haven't been encouraged to engage in these things in class. What they've often been told is, if you don't understand it, read it over and over again, highlight the material. If they haven't been told that by their teachers, they've often been told that by their parents or perhaps their siblings, or they just see other people doing it. And that feels good, because when you do that, you feel you understand it. Similarly, we get a similar reaction with active versus passive learning. When students are asked which they learn more from lectures or active learning activities, students will disproportionately say that they believe they learn more from effective lecture. The research, though, suggests that while students don't believe retrieval practice, space practice, and interleaved practice, as well as active learning, are very effective, they lead to significantly greater learning gains than what students tend to do. Listening to a lecture tends to result in very little long-term increase in learning. Rereading something multiple times creates what's called fluency illusion, where things look familiar. You recognize all the words, you remember the images on the page, you see how they're all connected. It makes sense to you and you think you've understood it until you have to apply it. Retrieval practice, space practice, and interleaved practice will make it clear to students often that they didn't understand the things they thought they did. And emotionally, that's much more painful than feeling confident that you've understood things because everything made sense when you read it or when you heard an instructor talking about it. So the problem is the techniques that are most effective, students tend to devalue. And so the challenge there is that we often devise classes that encourage them to engage in block practice, that encourage them to cram and so forth, because that pays off in the short run. And if they know they're only going to be tested on concepts once, if they know that they're not going to be tested on things from early in the class later, and they know that they have this big high stakes exam, they can cram for it and do reasonably well, but they won't remember more of it. So we have to build an environment that encourages students to build these habits, or that essentially create incentives for students to engage in this. So all the things that were posted on the Jamboard would work that way, giving students frequent deadlines, not requiring more work from them, but perhaps requiring students to spread their work out, giving them lots of opportunities to try things, to make mistakes and learn from those mistakes. It may not feel as good, but they'll end up learning a lot more. But that's only going to be fairly effective, or it's going to be most effective if they understand why they're doing that, if they embrace the possibility of learning from mistakes, and if they're in an environment where it's not going to be too costly for doing that. Well, in any case, those are the things I threw together, but I have put together some resources, and I'll share a link to that. It's not comprehensive. They were just a few things I had handy. Some resources on retrieval practice, on interleaved practice and space practices, as well as some implementations. And one I'd really encourage you to look at if you just want to try some new things is retrievalpractice.org. The people who put that together had worked in the Washington lab where the authors of Make It Stick had done a lot of research on learning. And they've got lots of examples. The book is Powerful Teaching, Unleash the Science of Learning. It's written mostly for secondary school teachers, but the concepts are really good. And retrievalpractice.org has activities that can work in any level of learning. And, you know, I think most of you have participated in some of the reading groups on other things. So these are just a few resources, and I hope they're helpful. So that's all I've got. So any questions, comments, thoughts?
Thank you. It's always useful to review all of these things.
And I know
Thank
you study a lot of these. This is all from educational psychology and research in psychology. So you've seen a lot of
but
it.
It's always good to have it thrown up in your face again to remind you why.
It's
why are you
retrieval
not doing
practice. Yes.
Exactly.
And I was listening to a podcast recently where someone was talking back about reviewing what other people were doing in classes and remembering that they had done some of the same things, but they had moved on to something else. And they couldn't even remember why they stopped using these techniques that they remember being really effective when they used them. They had just moved from there without really reflecting on why they had done it. It was an interesting discussion, because there's so much more I could do to make my classes better. I've done a lot with retrieval practice, and I've done some with space practice. Interleaved practice, it's been a little more challenging. But okay, well, that's all I've got. So any other comments, thoughts?
Thanks, John.
Okay, well, thank you.
Great day.
I'll stop the recording.